Good morning. My name is C.H. Srinath. My subject is Elements of Electrical and Electronics Engineering. My, my branch is Computer Science Engineering. Today's topic about power dissipation in a mixed circuit. Introduction to power dissipation. Power dissipation refers to the process by which an electrical circuit converts electrical energy into heat. Understanding power dissipation is essential for ensuring the reliability and efficiency of electronic components. Mixed circuits, which contain both analog and digital components, pose unique challenges in managing power dissipation. This is the picture of dissipation, energy dissipation in RC circuit. First stage, charging capacitor. Capacitor current formula is IC is equals to C dVc by dt. This is the formula of capacitor current. And next is importance of power dissipation. Power dissipation affects the overall performance and lifespan of electronic devices. Excessive heat can damage components and lead to circuit failure, making thermal management crucial. Proper analysis of power dissipation helps in optimizing circuit design and improving efficiency. Static power dissipation. Uh, the leakage current equation is the basic diode equation. This is the picture of static power. And next topic about types of power dissipation. There are two main types of power dissipation, static and dynamic. There are two, static and dynamic. Static power dissipation occurs when the circuit is not switching, while dynamic dissipation occurs during switching activities. Understanding these types is essential for designing efficient mixed circuit. Dynamic power dissipation. And next, power dissipation in analog components. Analog components typically dissipated power due to continuous current flow and inherit resistance. The power dissipation is analog circuits can be modeled using Ohm's law and the power formula. Power formula is equals to P. The power formula is P is equals to I square R. Managing power in analog components often involves using low power operational amplifiers and other techniques. Next, power dissipation is digital components. Digital components dissipated power primarily during state transitions, leading to dynamic power dissipation. The dissipation formula for digital circuits includes factors like capacitance and switching frequency. P is equals to C. Your third bullet. Dynamic power dissipation. This is the points of dynamic power. There are two components that add to dynamic power dissipation, and second one is capacitive load charging at a frequency f given by Pd is equals to Cv square ddf, and second one is the current that occurs during switching, which can be seen in the figure. This is the figure of this dynamic power dissipation. And next one is mixed circuit challenges. Mixed circuits combine analog and digital components, complicating power dissipation analysis. The interaction between these components can lead to increased power dissipation if not properly managed. Careful design and simulations are needed to predict and minimize power loss in mixed circuits. This is resistance in a mixed circuit. Step 1. Divide the circuit into series and parallel parts. These are the resistors, and this is a parallel. This okay. Next, thermal management techniques. Effective thermal management is essential to control power dissipation in mixed circuits. Techniques such as heat sinks, thermal pads, and proper airflow design can dissipate heat efficiently. Active cooling methods like fans or liquid cooling may be necessary for high power applications. These are the thermal management techniques. Next, next is the simulation tools for power analysis. Various simulation tools can model power dissipation in mixed circuits, providing valuable insights. Tools like SPICE and MATLAB allow designers to analyze power consumption under different conditions. These simulations help identify hotspots and optimize the circuit before physical prototyping. These are the batteries, PV array, battery, and converter, DC-DC converter. This series DC bus and grind. This is the last topic, grind. Next one is power optimization strategies. Optimizing power dissipation involves selecting appropriate components and circuit configurations. Using low power components and optimizing the circuit layout can significantly reduce power loss. Additionally, in incorporation power management ICS can enhance overall efficiency in mixed circuits. Dynamic power dissipation. This is the dynamic power dissipation. Low diagram of dynamic power. Load, capacitance, gate plates, diffusion plates, interconnects. Energy delivered by the supply during input 1 to 0. Next one is real world applications. Power dissipation considerations are critical in various applications, including consumer electronics and automotive systems. In mobile devices, minimizing power dissipation extends battery life and improves user experience. In automotive applications, efficient power management is crucial for safety and performance. This is a real world applications. And next one is future trends in power management. Future trends in power management. The trend towards smaller, more powerful devices is increasing the importance of power dissipation analysis. Emerging technologies such as wide bandgap semiconductors promise improved efficiency in power of dissipation. Future devices will likely incorporate advanced power management techniques to meet increasing demands. These are the pictures of the future trends in power management. Uh, First one framer, to second one ideator, third one research, fourth mapping, and fifth synthesis, and sixth roadmap, and seventh action. These are the implementation of future trends in power management. And next is a case study. Power dissipation in a mixed signal circuit. Analyzing a mixed signal circuit reveals specific challenges in managing power dissipation. By examining component selection and layout, engineers can identify opportunities for optimization. These case studies illustrate the practical application of power dissipation principles in real-world designs. These are the mixed signal design flow chart. And next one, conclusion. Power dissipation is a critical aspect of designing mixed circuits that impacts performance and reliability. Understanding the types, challenges, and management technique use is essential for effective circuit design. Continuous advancements in technology and design practical practices will pave the way for more efficient power management. This is the dynamic power dissipation diagrams. And next one is reference. Cedra AS and Smith KC 2019. There are feel free to modify any content or ask for additional details. Thank you.